Welcome to ZoomInData, your go-to channel for in-depth data engineering, analytics, and modern cloud technology interview preparation. In this video, we dive deep into the top 25 indexing and partitioning in Microsoft Fabric interview questions for 2025. Perfect for data engineers, architects, and anyone preparing for Fabric Lakehouse, warehouse, or performance tuning roles. We cover Delta Lake techniques, partitioning, clustering, Z-order, V-order, liquid clustering, OPTIMIZE, data skipping, file compaction, integration with SQL endpoints and warehouse, performance benefits, maintenance, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What is indexing in Microsoft Fabric? Microsoft Fabric does not support traditional row store indexes like clustered or non-clustered as in SQL Server, relying instead on columnar storage and Delta Lake metadata for optimization. Indexing equivalents include Z-order clustering for multi-dimensional locality, V-order for write-time columnar efficiency, and liquid clustering for flexible, incremental data co-location. These techniques use file-level min, max statistics and data skipping to avoid scanning irrelevant Parquet files during queries. Automatic features like auto-compaction and statistics collection serve as built-in index maintenance for analytical workloads. 2. What types of indexes are supported in Fabric? Fabric supports no traditional B-tree indexes. Optimization comes from Delta Lake clustering methods including Z-order, liquid clustering, and V-order. Z-order provides multi-column locality via space-filling curves, compatible with partitioning for read-heavy scenarios. Liquid clustering offers dynamic, incremental clustering without data rewrite, replacing rigid partitioning in modern runtimes. V-order enhances Parquet row group distribution and compression, applied automatically or via Optimize for general query acceleration. 3. How does indexing improve query performance? Clustering techniques enable data skipping by using min, max statistics to prune irrelevant files and row groups before scanning. Z-order and liquid clustering co-locate related rows, reducing I/O for filters on multiple columns and improving join efficiency. V-order optimizes columnar reads with better compression and distribution, accelerating aggregations and projections. Combined with automatic statistics, these reduce scanned data volumes significantly in large analytical queries. 4. How is partitioning implemented in Fabric? Hive-style partitioning in Lakehouse Delta tables uses partitioned by clause during creation, organizing data into subfolders by column values. Warehouse supports limited partitioning via create table with partition for range-based schemes on date or integer columns. Pipelines enable dynamic partitioning during copy activities based on expressions or source metadata. Partitioning remains physical in Lakehouse for strict pruning, while clustering alternatives reduce rigidity in evolving schemas. 5. How does partitioning improve performance? Partition pruning eliminates entire directories from scans when queries filter on partitioned columns, drastically reducing data volume. Enables efficient incremental loads and maintenance by targeting specific partitions without full table scans. Facilitates parallel processing across partitions in distributed Spark or warehouse engines. Supports time-based archiving and retention by dropping old partitions without affecting current data. 6. How does Fabric manage index maintenance? Automatic auto-compaction and fast optimize merge small files incrementally without full rewrites. Optimize command with ZORDER or VORDER triggers manual clustering and compaction on targeted partitions. Liquid clustering maintains layout incrementally during writes, minimizing separate maintenance jobs. Vacuum removes dereferenced files, with configurable retention for time travel safety. 7. How does Fabric choose optimal partition strategies? Recommends low to moderate cardinality columns like dates or regions to avoid excessive small partitions. Prefers clustering over partitioning for high cardinality or evolving query patterns due to flexibility. Monitoring Hub and Query Insights identify frequently filtered columns for partitioning or clustering keys. Balances with file size targets, 100 MB to 1 GB, to prevent small file problems or oversized scans. 8. How does Fabric handle large partitions? Applies optimize to bin compact large partitions into optimal file sizes with clustering. Z-order or liquid clustering subdivides data logically within partitions for finer skipping. Autoscaling distributes processing across executors for parallel scans of massive partitions. Incremental optimize targets only affected partitions to manage maintenance overhead. 9. How does Fabric manage index storage? Clustering metadata embeds in Delta logs and Parquet statistics with minimal overhead. V-order increases write size slightly, approximately 15%, but improves compression by up to 50%. No separate index structures, optimizations in line with data files in OneLake. Vacuum and retention policies control storage growth from historical versions. 10. How does Fabric support clustered and non-clustered indexes? Fabric does not support traditional clustered, non-clustered indexes due to columnar delta format. Liquid clustering and Z-order act as clustered equivalents for multi-dimensional locality. No non-clustered secondary indexes. Relies on statistics and data skipping for selectivity. Warehouse uses clustered column store by default for analytical compression and scans. 11. How does Fabric handle partition pruning? Physical partitioning enables directory-level pruning based on query predicates. Clustering uses file statistics for logical pruning without folder structures. Direct Lake and SQL endpoints leverage pruning for low latency power by queries. Automatic in Spark and Warehouse engines with no manual hints required. 12. How does Fabric optimize index usage? Automatic statistics collection ensures accurate skipping during query planning. Adaptive query execution refines skipping based on runtime conditions. Combined Z-order plus V-order maximizes both multi-column and columnar efficiency. Monitoring identifies underused clusters for re-optimization. 13. How does Fabric manage index fragmentation? Small file fragmentation addressed via auto-compaction and optimize binning. Logical fragmentation in clustering fixed incrementally by liquid or via optimize rewrites. Vacuum cleans up deleted or old version files causing bloat. Fast optimize skips optimal bins to reduce unnecessary rewrites. 14. How does Fabric integrate indexing with SQL endpoints? SQL endpoints query clustered delta tables with automatic metadata sync for skipping. Views and procedures abstract optimized layouts for governed access. Direct Lake mode benefits from clustering for fallback execution performance. No direct index creation. Relies on underlying delta optimizations. 15. How does Fabric integrate partitioning with Lakehouse? Lakehouse supports Hive partitioning for folder-based organization and pruning, combined with clustering for hybrid low cardinality partition plus high cardinality filter optimization. Shortcuts allow virtual partitioning across external sources. Incremental loads target specific partitions via pipeline parameters. 16. How does Fabric optimize analytical queries using indexes? Data skipping prunes files based on clustering statistics for selective filters. Columnar V order accelerates projections and aggregations in analytical patterns. Partition elimination speeds time range or categorical queries dramatically. Result caching reuses outcomes from frequent clustered queries. 17. How does Fabric manage indexing costs? Incremental clustering in Liquid minimizes rewrite costs compared to full Z order. Autoscaling charges only active optimization time, no idle overhead. Better skipping reduces overall query compute consumption. Monitoring tracks optimization impact for cost-benefit analysis. 18. How does Fabric handle schema changes affecting indexes? Liquid clustering allows key changes without full data rewrite. Schema evolution in Delta supports compatible additions with automatic sync. Partition columns require table recreation or rewrite for changes. Views abstract schema shifts to maintain stable query interfaces. 19. How does Fabric optimize performance using partition elimination? Prunes irrelevant partitions, directories early in query planning to reduce scanned data. Essential for time series data with date partitioning in large fact tables. Combines with clustering for multi-dimensional elimination. Enables sub-second responses in direct lake power BI models. 20. How does Fabric ensure data consistency with partitioning? Delta acid transactions guarantee atomic writes across partitions. Idempotent optimize prevents inconsistencies during maintenance. Snapshot isolation in endpoints provides consistent reads. Change data feed tracks partitioned deltas reliably. 21. How does Fabric handle partition switching? Fabric does not support fast partition switching as in traditional warehouses. Equivalent achieved via table renaming or shortcut swaps for quick metadata changes. Incremental loads with merge simulate switching semantics. Limited in warehouse, primarily Lakehouse focused. 22. How does Fabric support time-based partitioning? Common pattern with partitioned by year, month, day for date columns. Enables efficient rolling windows and archival by dropping old partitions. Incremental processing filters on time partitions naturally. Recommended for append-only or time series datasets. 23. How does Fabric handle partitioned data loads? Pipelines support dynamic partitioning via expressions in sync settings. Spark writes with repartition, or bucket by for targeted partition loads. Fast copy preserves source partitions when applicable. Incremental upserts via merge target specific partitions. 24. How does Fabric scale indexing and partitioning? Distributed Spark processing scales optimization across capacity units. Autoscaling bursts for large optimized jobs on massive tables. Clustering scales with data volume via incremental maintenance. No limits on partition count beyond practical file management. 25. What are best practices for indexing and partitioning? Prefer liquid clustering over partitioning for flexibility. Use partitioning only for strict low cardinality needs. Run regular optimize with ZORDER. Enable auto compaction for ongoing health. Choose moderate cardinality columns. Monitor skipping effectiveness via query insights. Combine techniques in medallion layers. Test impact on direct lake and SQL queries. Thank you for watching. If this video helped you prepare for your Microsoft Fabric interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth data engineering, analytics, and cloud technology interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.